Hi guys, today we're going to be discussing calculations and enthalpy changes, and the apparatus you see on the screen over here is called a calorie meter. Now this is an insulated apparatus that prevents heat loss to the surroundings, and one feature that does that is this lagging that you see over here in white that's in this beaker. Now this lagging is going to provide insulation, and this insulation is going to prevent heat from being lost to the surroundings. Now inside this yellow beaker over here, you're going to see this styrofoam cup over here in red. Now inside the styrofoam cup, you're going to have your reactants, which for this particular reaction are HCl and NaOH. So this is going to be an acid-base reaction. Now you're going to take a stirrer over here and you're just going to stir this entire mixture. Okay? So the first step for this is to run out 30 centimeter cube of HCl using a burette into the plastic cup. So this is the first step. So I'm shading HCl right now on the apparatus. So this is the HCl that you are going to run using the burette. The next step is to record its initial temperature using a thermometer. So you're going to take a thermometer and you're going to record its initial temperature. So the temperature before you added any other reactants, the temperature before you carried out any other type of reaction, this is going to be your initial temperature of the HCl. The next step is going to be to run out 30 centimeter cube of aqueous NaOH into a separate 100 centimeter cube beaker, and you're going to record a temperature for that. So you're going to have two beakers. One of them is going to have the HCl and the other is going to have the NaOH. And the temperature for both of these is going to be recorded. Now after that, you're going to add both of these together. So you're going to add the NaOH to the HCl. You're going to stir it and you're going to record the maximum temperature on the thermometer. Now the temperature is going to keep on increasing and it's going to reach a point where that temperature becomes constant. So that's going to be your maximum temperature and that's what you're going to be recording. So this is the procedure. The first step is to record the initial temperature of the HCl. The next step is to record the initial temperature of the NaOH. And your final step is to mix all the reactants together and to record the final temperature. So these are the three readings that you're going to be taking. So our next step here is going to be to calculate the moles for both the reactants. So the formula that we're going to use in this case is going to be moles is equals to concentration times volume, right? So N is equals to CV is the main formula that we have. Now, in this case, you're going to get 0.003 moles for HCl and 0.003 moles for NaOH. After that, what you're going to do is you're going to record the initial temperatures of both of them. If you recall, we already did that in the last slide. So we had two separate beakers, one for HCl and one for NaOH. So the temperature in HCl was 25.5 degrees Celsius, and the temperature in the beaker which had NaOH was 23.3 degrees Celsius. Again, these are just experimental values. If you carry out the experiment on your own, what you get might be different. So since you have two different values for initial temperature, what you're going to do is you're going to take an average. So you're going to add these two values together. You're going to divide them by 2. And you get an average of 5.4 degrees Celsius. And this is basically going to be your Ti, which is your initial temperature. So this is the value that you're going to use. The next thing that you're going to do is you're going to record the final temperature. Now, since the final temperature is going to be of the combined mixture, it's just going to be one value. So you won't have to average anything. And after that, you're just going to subtract them together. Final minus initial, and you're going to get 3.6 degrees Celsius, which is delta T. So this is going to be your change in temperature. The next thing that you're going to do is you're going to calculate the change in energy. Now, the reason why we're carrying out this entire experiment in the first place is to find out delta H, which is going to be the enthalpy change, right? So the formula for delta H is Q is equals to mc delta T. Now, Q basically refers to your energy. M is mass. Now in this case, we're going to take the density of your liquid to be 1 gram per centimeter cube. The reason for this is because when you add HCl in a beaker, you're adding aqueous HCl and you're adding aqueous NaOH. So your mixture is already dissolved in water and these are dilute solutions. So because of that, most of the mixture is water, and the density that we're going to use, we're just going to assume it to be the same as the density of water. So we're going to take it as 1 gram per cm cube. So this is going to be your density. Now the formula for mass is density times volume. Now this is the density and the volume that you're going to have is 30 centimeter cube. So your mass is going to be 30 grams for both of them. Now when you have a combined mixture, it has both HCl and NaOH in it. So you're just going to add these two together and you get 60. 60 is going to be your mass. Now C refers to the specific heat capacity, which is going to be 4.18. This is the constant and it's given in your data booklet. And after that, you have the change in temperature, delta T. Delta refers to change. So change in temperature, which has already been calculated, is 3.6 degrees Celsius. And you just multiply these values and you get this answer over here. Now, if you look at the equation, now mass is in grams, right? And specific heat capacity is in joules per gram degree Celsius. So if you cancel out certain quantities, you're going to see that the final unit is in joules, which is what you're getting. At the end of the day, you're getting energy, right? So after that, now what the value that you're getting over here is not delta H. Delta H is supposed to be per mole, but in this case, you don't have per mole. This is the amount of moles that you have, right? So normally, now if you had less moles of HCl, let's say if you had 0.001, you're going to go with the limiting reactant instead of what I've written over here. Now in this case, since the moles of both of them are the same, you have no limiting reactant. But when you're calculating delta H, you're always going to use the number of moles of the reactant that's limiting your reactant, right? So in this case, this is the amount of energy that's going to be released when you have 0.003 moles, and you need to calculate the amount of energy that's released when you have 1 mole. So you're going to get 300.9 kilojoules per mole. That is the energy that's going to be released. That is the value for your delta H.